All right, guys, welcome to ITS 450. Today we are going to work on our format string lab. I'm going to lay out the details for that lab. And we're also going to talk about any other questions you may have. Okay, so I'm going to begin just by going over some of the details. I know I went over the theory of the format string lab, which was memory, on Tuesday. So today I'm just going to get into more details of the lab. So first, let's go to the Brightspace. Actually, let's go to Brightspace, and I just want to give you some of the information here. You guys are seeing Brightspace, correct?
Yeah.
Yes.
Yeah.
All right. So format string lab. Okay, it's got the ask. So remember the goal of this lab. There, the main goal is there are two letters hidden in memory, uppercase U and uppercase D, I think. You have to do a lot of tasks, but really all of those tasks lead up to you changing one of those letters to the first letter of your first name. Right, so when I grade your lab report, I'm going to look at your name and then I'm going to look at the letter, and they have to match, okay, for you to get full credit on that problem. So that's what you have to do. So remember, I kind of explained all of this on Tuesday, but you have the ASCII code file, okay? These are just the slides. This is the Word document that you need to follow, so I'm going to go over this one today. And then there's two PDFs. So I'm going to talk a little bit about both of them. So I'm just going to start downloading these. And then I'm going to give you kind of an idea, commands. I'm going to give you a rough, like a recipe of how you can approach this problem. So that should definitely help you. Let me just open these files first. There's 4 files. Also, I will be creating the link here somewhere. In this module format string, I'm going to create a link for you to submit the lab report. All right, so I've opened those. Now I'm going to open up.
Where do we submit the lab for SET-UID?
I'm going to create a link for that as well. I wanted to talk to you guys about whether you need one more week for that one, and what I could do is just make both of them do a week from today. So we'll talk about that, but let me just go over this first, and then remind me, please, okay? If you don't mind. All right, so some of the files, ASCII code, as I said, you're gonna need this to find the letter. You got the decimal representation, hexadecimal. So you'll need that. Did you guys see that, what I just did? You didn't, huh? You're still looking at the, sorry. I keep forgetting. Give me a sec. The ASCII table, right? You're seeing it?
Yes, we see it.
Okay, so that's the ASCII table, as I said, the letters. Also, there's more files. There's 2 format string labs, if you will. You can read both of them, but I only want to focus on format string itself without worrying about code injection. So I don't want to make it, we're going to do code injections in the next 2 labs anyway. So I'd rather just do that topic in those labs. So basically then, if you're seeing, what are you seeing now? Are you seeing format string vulnerability lab? Is that what you're seeing? Guys?
Yes.
Yes.
Okay, great. All right, so this
Yes.
lab, look at it, it's got a lot. It's got the format string vulnerability part from the other lab, but then it's got these other things. These three things: code injection, shell code, reverse shell. And so it's a lot of stuff. It would make this lab pretty big, and it's actually two topics kind of combined into one. We're gonna do two labs on this anyway. The following ones for the buffer overflow, where we're, as you will see, we will basically, this just has a program, we'll have a program, and you will see it's got shell code in here. This is what I explained in class, and I'll explain more about this next week. This is, see, it's injecting shell code in here. And so I want to leave everything related to shell code. You can see that there's more shell code there. I want to leave everything related to that for the future labs. All right, so I'm not going to use this part of the lab. See, it's got all of that. But definitely start reading through it, okay? Read this. It'll give you, it'll motivate a lot of the things that we can do in the next lab. Okay, this reverse shell, it's something that we also cover in the network security class. And so, you know, I kind of have it divided like that. So in essence, I'd rather just do this lab, which is just a format string vulnerability lab. And this one just focuses on changing these two little secrets in memory. Okay, so it should be pretty interesting to get into the code. Also, I think this code is simpler, so it'll be easier for you to understand. All right, so we're just gonna do this. Now, read both documents, but at the end of the day, I create a Word document, and that's really what I want you to do. Okay, so that's really what I want you to do. So now I'm going to share the Word doc. Okay, let me share that. Okay, so here is the Word document. You should be seeing a Word doc. Okay, so these are the problems that you have to do for the lab. This is all you have to do. All right, so as I said, I've changed it a little bit just to make it a little bit different. So here we have, basically you have to take that, download the program voltprog, right? That's the program that's in that PDF. Okay, so that should be sharing, and you know, all this sharing takes a lot of work. Okay, so it should be if you look in this document, this program, right? voltprog, right there, you can see the title. You're gonna have to either copy paste it or type it up. Be careful when you copy paste something from a PDF, because some of the special characters like double quotes and things like that don't copy correctly. And you might think it's the right thing, but it's not. So I would almost advise that you just type it up. It'll save you errors. Okay, anyway, so you're going to use that code. You're going to compile it. Switch over. All right, so you're going to download or copy that program, voltprog, which is for the format string vulnerability lab. And then you're going to complete the following. So as I already explained a lot of this in the lecture on Tuesday, so I'm not going to repeat any of that. But basically, I showed you, okay, how do you crash the program? You're going to crash it, you know, as we discussed. And so that's the very first task. Go ahead, execute the program, and then see how it should operate normally, right? Obviously, type things and don't let it crash. Then in 2.2, use %s format string with a printf function to crash the program. Okay, so how can you do this? You know, how many %s's do you need? We talked about what %s is, what it does, right? What do you think happens? You should be able to answer that and show your results, okay? Then after that, in 2.3, we're gonna use GDB, all right? So GDB is, I'll show you a little bit of GDB this today, all right? And so you're gonna debug it with GDB. I will provide the commands to analyze data in memory. And so this should be very nice to look at memory and get a sense of what's going on. You will enter, so here's one thing I want you to do. I want you to enter your name or a word you remember, you know, Purdue or something, as input. And try to see where it is placed on the stack in memory. You're gonna have to look for it. Can you find the word you entered and show your results? So really what I want you to do is I want you to enter the word, and then you're going to try to find the address so that you can, or somehow you're gonna try to print your name, okay? So I'm gonna show you some things that we can do with, with the tools that we have. Then in 2.4, in this problem, you want to change the secret values U or D, right? So those are written in hex, I think as 0x44, 0x55, if I remember correctly. And so you want to change those parameters that are hard-coded in memory while they are in memory. So you're gonna need to craft an experiment where you use %x, %s, or %n to change one of the secret values in memory. Doesn't matter which one. But remember, you can't change things in the code. It has to be while the program is running. So you are in fact inserting code injections, just simple code injections, right? Not like later on, we'll do shell codes. We may even come back to the format string after the buffer overflow lab. That's something that, I'd actually do, but I want to, I don't want to get into that right now. So we're going to craft the experiment, or you guys will craft an experiment where you use %x, %s, %n to change one of the secret values in memory just by typing inputs on the screen. That is the trick. And that is the trick of every single exploit we're going to do this semester. It's very straightforward how they all work the same. You cannot change the code. Show your results. You can change the secret value of any random value. So notice here, all I'm asking you is that you change one of those secrets to a random value. I just need to see that it's random. In 2.5, it gets a little bit harder. It's the same. 2.5 is the same as 2.4, but you have to change it. So now that you have succeeded with task 2.4, you must repeat it, but this time you should insert a value that is predefined, such as the letter R, or preferably the first letter of your name. So, it would be the exact same procedure. And that's why I provided the ASCII table that you saw there with their decimal hex conversions. You will also need to modify the code of Volproc just to visualize the changes you made. So I want you to print the character strings, now there's two ways of figuring out the first letter of your name. You can certainly figure out the math. There's a way of figuring out the math, or otherwise just do trial and error. But you should be able to, just by trying several things, eventually figure out the formula or the equation, the pattern. All right, and that's it. So it should be a fun thing because, you want to succeed, right? Your goal for this lab is just to change that letter, play with memory a little bit, and using in particular the format string vulnerability at this time. Okay, format string vulnerability. As I said, later on, we'll look at more advanced things with shell code and so on. So I wouldn't worry about that now. And then 2.6 is just understanding the stack using GDB, right? So get a little bit of a more intuitive understanding of the stack just by exploring it, the address space, and so on. And then think about this question. Describe how an understanding of the stack and heap in memory could help to exploit a system. So I've already given you this explanation in the previous lecture on Tuesday, but just certainly, you know, think about it. Are there any questions about this handout? This is the handout of the questions that you need to do in the lab. Okay? Not the PDFs are only there to be read, but you don't have to answer the questions there. I mean, some of the questions are similar to this. I'm just saying you just have to answer the Word document. This should be a 1-week lab, it should be doable in a week. And so, yeah, that's next week. We're gonna look at buffer overflow. So we're gonna, you know, it's gonna continue build on this, but just get a little bit more complicated. All right, so now I'm gonna let you guys ask a couple of questions, and then I'm just gonna lay out the details of this lab. So are there any questions?
Nope, I don't think so.
Great, great, excellent. So let's then, so as I said, you know, I'll give you, I'm not gonna give you the solution, but I'm gonna give you a recipe of what you can do, just to kind of give you an intuition. So I'm gonna switch over to the board, the whiteboard. All right, so you should now be seeing the whiteboard. And so this is, you know, our format string vulnerability lab. Okay, so format string. Okay. So remember, the key question is that printf function. We also talked about the token, so you'll be using, and I gave you a table on Tuesday, %s, %x, %d, %n. So these are, so in particular, when printf takes in one of these inputs as an argument, printf performs, it tries to read wherever the CPU is, the registers in the CPU are pointing, it's going to try to read that block of data. And also it moves, right? And we talked about how some of these read by value and some of these read by reference. So that means that sometimes in the memory, sometimes in the stack, you either have actual values or you have addresses, which is an important concept to understand, okay? It's a pretty important concept to understand. So now, I'm gonna kind of give you a recipe of this, of how you can follow and solve it. So I'm going to create a new page here. All right, so let's first, you know, steps, let's say steps. Number 1, get the code. I already showed you what the code is. It's called volprog-c. It's in the PDF I showed you. Then you're going to, you know, make sure obviously you read through it. That's the first thing you should do. Just a lot of, in this class involves a lot of code auditing. So it's not you rarely have to write any code from scratch in this class, but you do have to read a lot of code. Okay, so code audit, read the code. Okay, then number 3, you're going to compile the program. Compile. Okay, so we're gonna do, you know, GCC -G-O volprog, and then volprog _ .c. Okay, so that's, you know, obviously compiling. Then once you have it, initially I just want you guys to, you know, try out your program. So on the terminal, you know, you'll run it. So it's called volprog. You should always check parameters ls-l, right? Make sure ownership, access control, all those details. That's always very important to check. And now you're ready for the first step. So the first question is, you know, run it. Type in the parameters that it's asking. You need to figure out which, it's gonna ask you for 2 inputs. So you need to figure out which of the 2 inputs is the insecure one, okay? Or the one with the vulnerability. Then, so run normally. Then, number 6, you're going to crash the program. How do you crash the program here? You're going to access, oops, going to access an invalid address in memory. Okay? So you need, so to do that, think about this. Should I use byval or byref format strings? I'm not going to tell you, but, you know, think about it. Okay? So, you know, I'm giving you the information really there. You just have to think about it a little bit. What number was I? So this would be 7. Okay. Okay, so that's, you know, that's the first question, right? Then the second one was, or that was 2.2. All right, 2.3 is GDB. So it says on 2.3, debug with GDB. Analyze data in memory. Enter your name or a word you remember, and try to see where it is placed in the stack and kind of print it out. So GDB actually has a lot of tools. I'm only going to give some basic ones, but some of this is very easy with GDB because GDB sometimes shows you the entire memory layout. It's not a, it's, you know, it's kind of like a terminal, but it looks, it's formatted well. So how do you run GDB? You just say GDB. Okay. I think it's called a GNU debugger or something like that. So let's say 8. Now you're going to run GDB dot volprog. You know, the vulnerable program, your executable, right? So you're going to run it with GDB. When that happens, it should give you something like this, something that looks like you're now in a prompt within GDB. So you're now in the GDB prompt. So what are things that you can do? So at this point, it's very much like maybe when you use Visual Studio or something, you put a checkpoint in your code at line 29. And so then you hit, you know, run, right? You hit run, and then the code executes, loads in memory, but it stops here, right? It stops there, And so now you can look at things, everything in memory, you know, over here, and all inputs and everything will execute. So whenever you want to add a breakpoint, you do B and then the number that you want. So let's say, you know, I wrote 29 there, so 29. You'll have to figure out the appropriate number. But that's a breakpoint. Let me out over here just say this is a breakpoint. You guys know what a, you know, I'm assuming you know what a breakpoint is, right? So pretty standard. Once you put the breakpoint, then you can do other things, like you can say run, R for run, and that will just run the program to that point. After that, you can start viewing the stack. All right, so you can now issue commands. GDB has a lot of commands that will help you to view things in memory. So that you'll have to explore the commands a little bit, but I'll give you, you know, a starting point. So you can do something like there's a command X / you specify the number, if you will, of like bytes in memory that you want to look at, specify some flags, XW, and there's other combinations of this, and you specify the register. Remember, the register is nothing more than in the CPU, it's got little like memory boxes, little variables called registers. And these usually have addresses in them, pointers. You know, they're called like the stack pointer or the frame pointer, or, you know, things like that. So I'm going to let you explore these registers, and you can try ESP or EBP or a different one. So I'll be introducing, as we discuss this this lecture, right? I will be discussing or listing some of these registers. Remember, they're basically, you know, like a pointer there, and then maybe this one points over there. They're memory, okay? That's how the CPU keeps track of things, okay? Another thing, so still an 8. Another command that you can try is GDB X/ls, and then here you can explore that command. There's a command to view something in a specific address in memory. Usually addresses in memory will look like this. They'll have 8 characters. Okay, this is an address in memory. I'll write that. Address in memory. All right, and so the idea would be that this address, you're saying that this address points to there where there's some data, and then XLS will basically print out whatever is there and show it to you, okay? So you have to get, again, remember, you have to play with, you have to play with these, right? Because some of them read the data by value, some of them read the data by ref. And so that's important because sometimes you just want to get the value in memory, sometimes you just want to get the address in memory, sometimes you want to read whatever that address is pointing to. Okay, and so you'll explore these individual format streams. Okay? And so that's one of the labs that you can try out. So these are some of the commands that you can try out this time. Does that make sense, guys, at this time? Are there any questions?
Not right now.
Great, good. So it seems like everyone's getting it. All right, good. All right, so let's keep going. So now, what I want, then after that, you're going to do, so you explored GDB, right? Then after that, that just leaves problems 2.4 and 2.5, which they're really the same. They're really the same. 2.4 and 2.5 are really the same procedure. Only one's a little bit more complex than the other one because you have to write first letter of your name. So you'll be running, and here for this lab, for format string, one of the things that you don't have to worry about, do I have the root privilege or the seed privilege? That's not relevant for what we're trying to do. So you can, run the program, vol prog, okay? When you're running it, the first thing you want to find out is you want to find out those secrets, right? So the secrets that store 0x44 and 0x55, which are the letters U, oh, sorry, it's backwards, which are the letters uppercase D and uppercase U. So this is, the little table. This is hex. And then this one is char. All right, and so you wanna basically, explore those secrets. And in particular, you wanna figure out, what is the address? Where is it located? Okay, where is it? So when you're running the program and you're trying to, after you crash it and now you're trying to find out data, remember that when you enter these characters, like, the whole key, again, I remind you, it has to do with the printf function. So this is where the printf function becomes really relevant. Printf, as it's written in that code, basically has input, just a variable like that with nothing else. And you can write whatever you want on that variable input. You can literally write whatever you want on that. And so that's why we've said, well, when this program, volproc runs, it's got variables. So those variables, the U and the D, right, they're in there somewhere in memory. So you want to find out where they are, read them, and then you need to change one of them, okay, to a specific thing. And so so in this case, you want to do, we already discussed that whenever printf takes in %s or a %d, whatever, it has the behavior that wherever the register is pointing, it's gonna read that and advance the register to the next position. So that is to say, like, it would advance to this D and then to that U and then to whatever, okay? So you're going to use that mechanism, to basically create this movement across the memory and also read it out, right? Read it out because it's gonna display it as the print function. Okay, so let's do 11 here. So now, assuming you ran volproc C, you're somewhere in the, it says something like enter input, and you've identified that that's the vulnerable place, right? You've identified that that's the vulnerable place. Then you're going to now enter a combination of %x's or %. I'm not going to tell you which ones. I want you guys to figure it out, but I can give you some hints. Again, the trick is some read data by value, some read data by reference. Think about that. Also, I've said this many times, but I'll stress it again. Some of these are values. Some of these are addresses. Okay, so you can then, based on that, figure out what you should do. For readability, put a period in between them. That way, it'll write, blah, 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 period, blah, 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 period, blah, 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 period. And you can make sense of each individual thing. And one of these should be U, right? So the question is, you know, are you going to get a decimal U, a hex U? Are you going to get the address of U? That's, you know, in a nutshell, you know, what do you get, right, when you do this? Do you get the letters U or D as, and so these are the options, you know, a value, decimal, a value, hex. Do you get the address pointing to them? You know, that's what I want you to play with and really understand, okay? That, you know, that, because this is really important. Understanding this simple concept in this lab is very critical to understanding the buffer overflow lab. I can tell you the buffer overflow lab is, you know, a little bit harder, but it builds entirely on understanding these ideas. And this is a much simpler lab just to play with the stack. Okay, now, how many of these do you have to create? The stack is not going to be very big. And I can give you a hint that if you're going in the stack, if you've moved in the stack 20 positions, that's too much. So the range should be somewhere between, you know, like 2 and like 16, let's say. Somewhere along those. I'm not going to give you the exact number where they're located, but I'm making it easier by, you know, understanding this. Okay? In the future, the problems are obviously the space where we're searching is going to become way bigger, but still not infinite. It's going to become a finite space. And from there, we're gonna learn about something called a knob sled. If you've ever heard of the knob sled, you know. But anyway. All right, so you'll have to figure that out. And then once you figure out where the letter is, you got to figure out which special character would allow you to see where it is, you know, all of that. Okay. Does this make sense? Are there any questions so far? Okay, I'm going to assume that's a no, no questions. So then let's continue down here. I'm going to use up this space. I recently learned that you only get 20 slides, so I'm going to maximize my space. Now, the harder part in the last one, or actually in both 2.4 and 2.5, 2.4, you just have to write a random. In 2.4, you need to write a random letter in memory to replace U and D. Okay, so you need to do that. So as it turns out, we can use the %n for that. %n by definition writes. Okay, so now the question is, and %n, once you've identified, you know, let's say you have this, right? And you did it, you know, you were looking to see where the letter is in memory and you found that it's here. Once you find where it is, %n basically, you know, if the stack is pointing there, right? And then %n will just write to wherever it is that it's pointing. So you just have to place it in that location. Where the U is, now you place the %n. Now, so that should be pretty easy. Once you find the U or the D, all you have to do is replace whatever you had in there with percentage n. Percentage n will write to that location. And then you'll be able, once you finish executing the program, you'll see that the variable has changed. In this one, it doesn't matter. In 2.4, that's why I left it random, because you can just plug in percentage n as you're searching. Most likely, it's going to have a number. Remember that percentage n prints the number of characters, or returns the number of characters printed so far. So it's going to return a number and write it there. It's going to return a number and write it there. And so it'll return a number and write it there. And it's going to be whatever that number of characters is. So, you know, it'll probably change your U to whatever, some random number. Okay? However, in 2.5, you will have to, in 2.5, you will have to select now, be more precise, right? So in 2.5, you will write the first letter of your first name. Okay, so you'll have to do that. And now you still use percentage n, but you have to play with, so if the definition of percentage n is that it has a number, so it has some number based on the number of characters that have been printed out so far. So that's like saying, you know, I have dot dot percentage s, you know, dot dot 3 7 percentage n, right? So percentage n really counts like all of that. How many of these have been printed? So let's say that gives you, I don't know, I'm just going to make up a number, 43. Well, if you want that to be different, try another one. So, you know, dot, 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 more percentage s, maybe, you know, you can say like 0.000 percentage d, you know, dot, 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 percentage n. So if you look at that, this one might, that percentage n will say, oh, that's 72. Do you see that? Because it's more characters that have been processed. And so you will just have to figure out the right combination that gives you the decimal that is equivalent in the table, right? In the ASCII table that I gave you, you got hex to decimal to characters. And so that's all you have to do. Because as I've said a couple of times, a letter U is actually stored in memory, whether you give it in hex, in string, in integer, it's always saved in the same way. So the operating system will make sure that that decimal gets converted, let's say to hex, and then when it comes out, it'll come out as a number or the appropriate letter. Does this make sense, guys? How to use the percentage n to write your the first letter of your name?
Yes.
Okay, great. Excellent. That's really great. All right, let's see what else. Okay, I gave you, there's a few registers that you can play with. There's also another register called EAX, right? I do encourage you to go online and just kind of look up all these registers, you know, what they mean. You know, this is not meant to make you guys be exploit engineers, but it's made you to open up your eyes to how those exploits actually work, okay? Because as I said, at the end of the day, we want to get a terminal going. Or a reverse shell, whatever. Any code that we have, we can always just write it as shell code and insert it. And then, you know, we get the we get the effect that we want to get. Mind you, what we're doing right now is only changing parameters in memory with the permissions that we have, that our user account has. So we're not doing anything to exploit effective IDs or real IDs. Remember that what relates to those IDs and stealing the root privilege comes from the previous lab, which is the SetUID lab. But I can tell you that next week, a couple of weeks, we will be combining all of this to actually get a root shell. All right. A few other things. Let's see. Let's move on. So a few other things you might want so understanding the stack. Okay, so a few more things you want to do is, in GDB, I already showed you how that would work. In GDB, right, you can try other commands, again, just to view what's in memory. Get a feel for what are these pointers pointing to in memory. Now, one thing that and this is more towards the next lab. I'll say this again later. But let's say that you have a program. Right? You have a program, and the quiz that I'll give you, the practical exam, actually involves this. You'll have, let's say, a function, another function, and another function. And let's say you just want to take that code that's there and convert it to the shell code. So how do you do that? Well, there's a process, right? The process is that you go in there, the GDB, and you're going to do disassemble. And let's say this one is called main. So you do disassemble main, right? And then that's going to give you like the assembly code. And then there's another step where you have to take those commands from the assembly code and convert them into what are called the opcodes. And then the opcodes would be basically the shell code, the actual thing that you can inject. You don't have to worry about this for this lab, but just be aware. I'll introduce this topic again in the next lab. And that's so that we can, like if you honestly wanted to get shell code from any program, that would be the procedure. However, all the shell code that we're going to use is going to be provided for us. So the X just means looking up information in memory relative to that register, okay, relative to that register. Okay. So actually, this lab, it's not as hard as it might seem. It's pretty straightforward. There's no serious trial and error. It should be pretty clear, I think. But certainly, I want to make sure I've covered everything. One thing I do want you to do is I want you to make sure that you can modify your C code just so that at the very end you can view, okay, the letters were U and D first, but now that I've made my change, the letter is actually, let's say your name is Mary M. So what I mean in the lab is, because if you give me the hex value of it, I have to look it up in the ASCII table. So that's just gonna, I'm gonna have my ASCII table open, but if you just give me the letter and it's printing it, and I see the code is printing it, I'll know that it was right. Otherwise, if you have the shell, only have the hex there, I'm gonna have to look it up in the ASCII table, and I could make a mistake and think, oh no, they didn't get their the first. So by providing the letter, you're just, you're ensuring that I don't miss anything. Okay. All right. Let's see. Does someone have a question? Let's see. Sorry, it takes me a while to get to this chat. Okay. All right, so let's keep going then. In the GCC, I gave you, if you notice, in the GCC, I gave you a command like this, GCC -G -O. The -O is for the name of the output, prog C. Just be aware that this -G is required for GDB to work, right? So whenever you compile -G and you want then that executable to run in GDB, that needs to be in there, okay? So just don't forget about that. Yeah, we'll be using this, as I said, for the next 2 weeks because all these labs are related, and so they build up to just one single thing. All right, so I'm gonna make sure. I think you pretty much have everything you need for this lab. All right, so that should be it as far as the format string lab, okay? So at this point, you should be able to solve this. Are there any questions about the format string lab? Is everything clear?
No, I think we're good.
All right, good, excellent. That's really good to hear. Okay, now let's move to the SetUID lab. So we had talked about that one. And I believe I gave you all the details on that one as well. So I'm just checking. Otherwise, I'm just going to open the floor to questions on either one of these labs. So remember, in the SetUID lab, all you have to do is you have to root owns a file that only they can see. You change the permissions. That file can, if you try cat with the seed account, you cannot read it. But then you're going to create a program that has a system call. And the program is owned by root and is SetUID. And then you're also going to play with individual or different bash dash CSH. And you need to tell me if you are successful in reading that file, even though you're seed, and even though it is root owned, and even though it is, you know, inaccessible. Did you find a way to read that file? Okay, and so that's what I need to know. You know, that's ultimately what I'm looking for in that lab. I'm not really looking for anything else but that, because everything else is just like, you know, practice this, practice that. But that's really the objective. So now, SetUID, are there any questions on it? Did anyone succeed? It is due tonight. Do you guys, are you all set for submitting tonight, or do you want me to extend this by 1 week? Only for SetUID. Remember though, you'd have 2 labs due next Thursday.
Can you extend it, please?
Extended, okay. And so then you're gonna have 2 labs though due next Thursday, okay?
Okay, thank you.
All right. So then, do you guys have questions then on it? And I think I've enabled share screen. So you can just go ahead, if you have questions, share your.
So the set UID won't be due to next week.
That's right. That's what I'm doing. I'm extending the deadline. But
So there won't be a submission box till next week then.
I'm gonna create it today, both of them.
Oh, okay. So you can submit if you're done already.
If you're done already, yes. If you're done,
Okay.
I just thought I'd have questions. Now, bear in mind, guys, you know, these are two very important labs for the other labs. And so I want to make sure, you know, everything was done correctly on those. I think format string is more obvious. Set UID is less obvious when you got it to work. So if somebody wants to ask questions, go ahead. Otherwise, you know, I'm really, you know, I've gone over the labs for today, right? So it's, you know, it's a lab. So what I'm gonna do now is I'm gonna stop recording so the video is not too long, and I'm just gonna be here answering your questions, whatever question you might have. You know, go ahead. Make sense? So I have share the whiteboard. Okay, so remember, there's a root own file. Are you seeing the whiteboard?
Yes, sir.
Here.
Yes, yeah.
Root owned, and this is a secret. When you're seed and you use something like cat or any program and you try to read it, impossible. But then you created a program, myprog. This program has a system call in it, right? That's that function. And then in here you have something like cat. Let's call this secret.txt. Right? So cat secret.txt. Do you see that there? It's literally the same thing, right? Because over here you would just do it on the terminal as seed. You would say cat secret.txt. They're literally, both of these are exactly the same thing. Okay, only one is just done on the terminal. The other one is done through C++. C++. But you're literally just doing the same thing. So the difference is that here you are definitely seed. And this is root own 0. So it will never let you because of access control. But the problem is myprog.exe, let's call it, if you look at the flags of myprog.exe, first of all, it is owned by root. Right? That's the key thing, guys. Right? That it has to be owned by root. Make sense?
Mm-hmm.
So the owner is, and then in the parameters, you know, read, write, whatever, but this has to be S, right? Set UID. And I gave you guys the command for set UID, which is something like chmod 4755. So what's going to happen now? That C, now remember, and this is the key thing that I look for in this lab. This command, if I see your command and it reads like this, myprog.exe, and even if you read the file, but if I see that is wrong, okay? It's gonna be wrong because it has to be that you are running it as seed, right? I need to see that, but you're running myprog.exe, which is this one. So you are literally running a set UID program. Got it? And this program, then what it's gonna do is, think about it. When it runs, right? what does the code look like? It looks like that, correct? Are you following me?
Yes.
Okay, so when you run that program, you're literally running this. So you're literally running that, which means you're literally running that. And whenever you run that, you call the shell, sh. Do you remember? I'm writing too high, I think. So whenever you do this, let me write down here. So when you run that, you're literally calling your sh. Remember what sh is? Sh is the shell that you have associated with your account. Now, Austin's question was, when should this work? Because that sh is only a, what was this called, guys? What was this called? The thing that we have with sh, what is it called? We talked about it. Symbolic link, right? Symbolic link. And I gave you the code, or it's in the PDF, the commands that allow you to break that. So Austin's question was, I have these two shells, right? And I'm gonna break that symbolic link and connect it again and so on. There's another one, dash. I'm gonna play with them. So if he doesn't do anything, like if sh is not really, modified, when you do this and run in a set UID and everything, will it still work? Remember that this program is spawning another process. Okay? Do you understand that? Why am I saying that it's spawning another process? Because my prog.exe has a context, which is that in memory, right? But when I do a system call within it, it's almost equivalent as if I'm creating another one. Now there's this system call, right? It's a cat. So I've literally created, like I've spawned, I've now duplicated my process into a second process. So this is process 1. Now I have a process 2. But a good shell in a good operating system would say that is very dangerous. Very, 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 very dangerous, because if I'm root in my effective ID, right, I'm going to need to have an effective ID here as well. What is that going to be? Do you guys see the absolute danger here? Okay.
Yes.
Yeah, so this is the danger. Because if this copy is the same as the original one, and that is root, you literally have
Root.
the root,
Privileges.
right?
I think I have a question. Oh. Hello?
Yeah, there's somebody in the background, man. Okay, let me see if I can mute them. Wait, guys, please mute your microphone if you have noise in the background.
Hey.
All right, yes, sir.
Yeah, so for how I approached the problem was I created a program and a separate text document, and I solely assigned it to root only, who could edit and view the document. And
so
then
that's the document that should only be viewed by root, correct?
Yes, that's
Okay,
correct.
fine.
And then I used the ZSH because it gives you the root privilege.
Yeah, but that's not what I want. I understand what you did. You just ran it from CSH, and it gave you the root privilege directly, and you viewed it that way, right?
Yeah.
That's not exactly how I want you to run it, because you're missing actually this point. That's probably what brought your question, is because what you're doing is missing that point of spawning the the different process, which is really critical as we move into the next 2 weeks. Do you understand what I mean, Yash?
Okay, so if a program is solely owned by root, then how would you run it in the first place as a seed user if you don't have the
Because it is, well, that's that question you just asked.
Well, you have to set
Answered by
UID, right?
It's answered by set UID.
Okay, and then you spawn another process because of you have the temporarily
Look,
privileged.
so think about it this way. This program, myprog.exe, right, should only say something like X there, right? Read, write, and X, right?
Mhm.
Yeah.
Correct.
In the normal world. And then what you're saying is totally right. If it looks like that, only root can run it. But remember that there are situations like when you change your password, when any regular user needs to access the shadow file, which is owned by root. And so there's gotta be a way around. Set UID is a workaround of a work around access control. And so here, the chmod 4755 of myprog.exe changes the execute from X to S.
Okay.
And by doing that, the program is now set UID, which means that seed can in fact run it.
Yeah. Okay, makes sense.
Got it?
Thank you. Yeah.
Okay, great. And so I want to finish what I was saying, because what I was saying is actually quite crucial to what we're doing next week. When you guys have myprog.exe, it's one process. As you know, you are seed, and your real ID is 1000, but your effective ID, because it is set UID, is going to be 0. Which is really dangerous, but it's fine. But in the program itself here, you have this dangerous thing, system call, where system call is equivalent to you typing in the shell cat secret key. Now, cat secret key is harmless. It's harmless at this time. So we're going to see later on something else, but this system call here is the danger, because that will spawn another process, a second process, and that second process needs to have parameters. And so now the problem is you were still seed, right, 1000, but if you retain the effective ID as root, this is now a process that has the privilege. And so that's what this is simulating very simply, is that so that's why we are now able to read the file, because whereas before we ran this cat and it didn't work, now we're running this cat, but we're running it in the context of the fact that it spawned from a root ID program. Do you see that, guys? And system call, when you do system call, you're actually going through SH. It's like you're literally in the terminal making a call to your shell. And so SH then needs to be the control. SH needs to say, okay, I know what's going on here. Boom. I'm not going to allow that. Okay, you're real, your user ID, but guess what? No way. You are downgraded now to your own real ID. So it doesn't matter. What happens is the cat will still not work. You see that, guys?
Yes, so you're not supposed to, as a regular user, be able to have access or see that file, right?
You should not.
Yes, okay.
Properly, hold on, in a properly working environment, that's a definite access control issue. However, so if pointing to bash or dash, these bash and dash are literally themselves programs, right? They're code as well. So this is code. Bash or dash, you know, they're shells, interpreters, right? So if they have the right code, they will notice this immediately and change that effective ID. However, what Austin said was, what happens is if I change the symbolic link to CSH? Do you understand, Susanna?
Yes, so CSH doesn't have that restriction in a way to, you know,
Exactly.
hey,
CSH,
like bash. Okay.
yeah, think of it this way. CSH is missing an if statement or two. It's not checking, hey, what just happened? Did I just see a spawn in the process? Should I change the effective ID to match the real ID? It doesn't, so whereas this has an if statement, this one is missing it. Who missed it? The programmer who wrote this code. But missing that little thing creates a huge problem. So in summary, in the lab, what you can do is change the symbolic link from bash to dash, right? Try it. Always ask seed. It should not work. Switch again to CSH. Always ask seed. If CSH has that vulnerability, you are able to read the file. Ask seed through the myprog.exe, which has a setuid functionality. That's why I said this lab is a little less obvious, but it is very critical to understand. Does this make sense? Susanna?
Yes, it does make sense.
Okay. Two things. One, very important, all of you pay attention, guys. So it's kind of a warning. Do not turn off your machine and leave SH pointed to CSH. It causes a problem where sometimes you can't log back into the machine, and you're gonna have to literally like do some. The Seed Labs has a manual on how to fix it, but you'll have to email me and I'll send you the manual to fix it. So write down, make a note when you do this lab. If you put a symbolic link to CSH, make sure that you link it back to bash or dash. Okay? It's possibly a security mechanism there so that people don't forget. But very important. Got it?
Got it. Thank you.
Got it.
The last thing is I need to make the transition of this idea to next week. So why is this important next week? So let me do a new slide. So again, we had myprog, prog.exe, right? And I had it similar to this, myprog.exe. It is process one, and it has a real ID, an effective ID, and all of that. We already learned that we can have a system call, and we hard coded the system call just to be cat some file, right? And we know though that this system call can spawn process 2. And if there's vulnerabilities in there, we can retain the effective ID. However, there's an even bigger problem. If you think about what we're doing in this week's lab, format string is a printf with an input, which is supplied by the user. It's a user supplied input. Now imagine if I combine those two ideas, and instead of hard coding the what goes in the system call, I just plug in a user provided input in the system call. Now that is even more dangerous because now you're going to try to spawn another process, a process 2 through the system call, and it can be whatever the user types in there. And so now instead of always just getting cat, what the attacker will try to do is they will try to create a terminal or a shell or a reverse shell, whatever, you know, reverse shell or a shell, it doesn't matter. But what they need to do is they need to find what is this program in C. I'm going to find, how do I write that in C? And then I'm going to convert it into hex. All that. And once I have that in hex, I'm going to, whenever I get an opportunity on the terminal to type something, guess what I'm going to type? I'm going to type that in there, which will go in here, gets a system call, and now you spawn a process that can be whatever you want it to be, like a reverse shell. And so this is how you get a reverse shell. Now you might be comforted in saying, okay, I can get a reverse shell, but bash will make sure that the effective ID will be 1000. So in essence, you'll get a reverse shell, but it's still your user. So you're not gonna, but in fact, next week, the additional thing we'll learn is that we can bypass bash. And so in essence, you could get a terminal with the root privilege. Make sense?
Yes.
That's why these two labs are so essential, is because they're the foundation for what I just described. This is the buffer. We exploit in there the buffer overflow vulnerability, but it really, there's a lot of concepts involved. Okay? All right, so it seems like everyone is understanding, which is great. Let me know. I'm gonna pause the video recording again, and I'm just if you have questions.
Yeah, no problems here.
Yeah, GCC should. So let me have my VM open. Let me. So all you have to do is you type GCC. That's it. So you have to have the appropriate program -G. Oops, sorry. You have to use the seed VM, right? Remember, maybe someone is not using the CVM, and then myprog.exe, myprog.c, and that's the command. And I don't have a C file right now to compile in here, but that's what you should do. See, it says no input files, compilation terminated, but that basically means that GCC is there, okay? Did I answer your question? If it's not finding it, as I said, the problem might just be that maybe you're not using the CVM, which you really should. So we're gonna stop here for today. I've created the two drop boxes to submit your assignment. Remember, those are due next Thursday. And next Tuesday, we will begin our discussion of the buffer overflow attack. So now that you understand these ideas of these two labs, we'll be able to move on to the next set of ideas, really to combine all of this together into a single thing, okay? All right, so if there are no questions, we'll stop here for today, and I'll see you guys on Tuesday. Have a good weekend.
Thank you, Professor. Have a nice weekend.
See you guys.
Have a nice weekend.
Have a nice weekend.